Hey guys, in this video the brilliant Mr. B is going to be taking you through histograms, working with them, drawing with them and interpreting them. There are 15 different examples here and the pinned comment down below will take you to the different points. If you want more examples, more practice questions after this, then there are loads more waiting for you over on my website.
Have a look at histograms. Now histograms are a kind of modified bar chart. What you'll notice with the histograms is that at the side on the y-axis it says frequency density. It doesn't say frequency like a bar chart might say. So if you have a look at our first table, draw a histogram for height, and then in between 120 and 136 centimeters, we want to draw 320 people. We want a frequency of 320. And if we have a look at the axes I have drawn here, the frequency density only goes up to 40, doesn't go up to 320. So what on earth do we do? Well, that 320 is the frequency, and we want to have the height be the frequency density. So what's that? Well, as well as the frequency being important, the other thing we need for frequency density is the width of what we call the class, the kind of group. So if our group is in between 120 and 136, we want to ask ourselves, how wide is that group? How wide would it be from 120 to 136? It's going to be a width of 16 centimeters. Starting at 120, if you add on 16, you get your 136. So we call that the kind of the class width. So what's the frequency density? Calculate the frequency density, you might see written as FD. You take the frequency, which was 320, and you divide it by the class width, which was 16. We're going to use a calculator for this, and these will be calculator questions. So 320 divided by 16 is going to give us 20. So frequency density, the first group, is 20. So how do we draw this on the graph? Well, firstly, you look at the class width. So we're going in between 120, so we'll mark off 120 in pink, and 136. So we'll mark off 136 in pink. That is the class width. That is how wide the bar is going to be in the histogram. You might think in a bar chart, all the bars have exactly the same width. In a histogram, they can have different widths. The next thing to find, the frequency density, we calculated that that was 20. We can find 20 on the frequency density, and that is how high our bar is going to be. So let's draw it in. It's going to be 4 across at the bottom, because that's the width, so it'll be 4 across at the top. And the height, we're going up to a frequency density of 20, and the height is going to be the same on the left and on the right. So we have drawn our first bar on our histogram. Now we'll talk about why the widths might be different, why we have this complicated calculation as we finish drawing our first histogram. And what I'm going to do as well, I'm just going to cross off the first row in the table so I know that it's done. Now I'm not going to write out the calculation for all of these, but essentially we're doing the frequency density calculation for all of these. And let's just write it out in words. The frequency density is equal to the frequency divided by the class width. And so this is the calculation I'm going to be doing for every single question. I'm going to do 25 of these calculations to make all of these diagrams. So let's look at the second row of the table. We have 192 people total to represent. That's the frequency. We need to divide it by the width of the bar, going in between 136 and 152. And so you think to yourself, what can I add to 136 to get 152? You have to add 16 on to get there. So the width is going to be 16. Divide the 192 by 16, and the answer I get is 12. So how do we draw the bar? So the width of the bar, as we discussed, was 16, and it goes between 136 and 152, and we can see that this is 4 squares across. So at the top it will also be 4 squares across. Now where's the top going to be? Well, 192 divided by 16 got us 12, so it's going to be at 12. Then we can just draw the sides, and I'm going to colour it in. I'm just doing this in a different colour, just so you can see the difference between the bars. Usually it's be drawn in black and white, and it wouldn't be colour coded. I'm going to cross out the second line because it's been completed, just so I don't miss any out. Now for the third line, we're going in between 152 and 168. And again, that looks like it's 4 squares across. It looks like it's going to be 16. 152 plus 16 is 168. So when we're saying that 288 people are going to be represented in this bar, we have to divide it by the width, and the width is 16. And this is going to give us 18 as our answer. So we're going to go all the way up to 18 on both sides. So there's 16, so one more square for 18. 18 is in between 16 and 20, and then cap it off at the top. And again, the colour coding is just there to make it really clear the differences between the bars. And let's cross that out. Now we've finished it. Now looking at the fourth line, so between 168 and 184. So it looks like we've got another one that's got a width of 16. The total number of people there is 160. We have to divide it by 16. And this is going to give us 10. So if we've got a width of 4 at the bottom, we're going to have a width of 4 at the top, which will be going through 10. Join up the rest of the bar and colour it in. And now for the next one, between 184 and 200, that's going to be another width of 16. So all of these are the same width, but as we look at the other diagrams, that's not always going to be the case, but we'll see that later. For the final bar, we have 288 as the height. The width is 16. We divide them, we're going to get 18 as our answer. Join up the bar and colour it in. So in our first histogram, they're all still the same width, and we'll talk about that later. But if we look at the heights, what we've done is maybe made it a little bit easier to do. We've not had to draw really high bars, going up to 320, 192, numbers like that. We've kind of shrunk the height down a little bit to make it a little bit more manageable to draw them onto a graph. Now, yes, the calculations have been more complicated to get them to be smaller numbers. But as you imagine looking at the kind of the y-axis and trying to find exactly where 192 is, that's probably going to be quite difficult. And to fit 160 and 320 on the same graph, it's going to be quite a high graph. So the first thing about histograms is it's shrinking down the bars just to make it a little bit more manageable to draw. Now looking to draw a second histogram, which is also looking at heights of people, but it'll be a different group of people. So again, we're going to have a look at the widths of the bars. So firstly, from 120 to 136, we're going to have a width of 16. And what we need to do is divide the frequencies by that width to get the frequency density. So if 80 people are in that height range and the width is 16, we do 80 divided by 16, and that's going to give us 5. And 5 is in between 4 and 6. It looks for this one, the frequency density, we have a different scale at the side. In the first question, it went up to 40. In this question, it's only going up to 20. That's another change that we have. The second group is in between 136 and 152. So we mark that off. And that's going to be the same width. So that's going to be another width of 16. We're going to divide the total by 16. So 96 divided by 16 is going to give us 6. So if it's 4 across at the bottom, it's going to be 4 across at the top. 4 squares, because each square is representing 4. 4 times 4 is 16. For the third bar, it's in between 152 and 168, another width of 16. So we'll take our total, 176, and we'll divide it by 16, and we get 11. So if it's 4 across at 0, it's going to be 4 across at 11. In between 10 and 12. We're going to join the bar up and we're going to colour it in. You might also be starting to notice here that there are no gaps in between the bars on a histogram, and you do tend to see gaps on bar charts. With histogram, you'd never have gaps. Now for the fourth line, now I've not been ticking these off, so we've done the first, second, third. So now we look at the fourth, and we're in between 168 and 184. Again, looking at the same width, so we're dividing by 16. So 144 divided by 16 gives us 9. We're 4 across at the bottom, and we're going to be 4 across at 9. This is in between 8 and 10. Join up the bar, and again, just colouring it in different colours, just to make it stand out to you while you're learning how this works. It would normally be drawn in black and white and not filled in, not coloured in. Cross out the line so you know you've done it. And then for the final one, we're between 184 and 200. The height's 80. Now we've already done one with a height of 80 and a width of 16. That was the first one, and it had a height of 5. So if you do have the same answer, you can just copy the same size and shape of bar. Do make sure that the frequency density and the width are the same before you do that. If the width was shorter, you'd have a much taller bear, which we're going to see in some of the next questions. Moving on to our third question, and again it's another set of heights, many more people included in this group this time, and we have some different group sizes to deal with. But we are going to start off the same. We are in between 120 and 136. We've got a width of 16, so we're going to divide the total 600 by 16 to give us 37.5. Now, you need to do this as carefully as possible, as accurately as possible. But don't worry if you're a little bit off. Now, 37.5 is going to be in between 35 and 40. Actually, we do have a nice line there we can use. But if it wasn't possible to put it on the scale, just try and get it as close as possible. You'll be added a little bit at either side. So, much taller bear here than what we're used to. Moving on to the second row, we're in between 136 and 152. Mark that off. That's going to be another width of 16. So 400 divided by 16 is giving me exactly 25. So let's draw the bear down from 25 and cross off the line so we don't get mixed up. We know that we've done it. And now we get our first bear with a different width. Now the total is 660, but the width, it's in between 152 and it's in between 176. This is a wider bear than what we've had before. Now, what's the width of that? Well, one way to get the width is to take the largest away from the smallest. 176 take away 152. What we should be getting is 24. So if the width is 24, we need to divide by 24, and 660 divided by 24 is 27.5. So I'm going to start drawing the bear now all the way up to 27.5. And remember, it's going to be much, much wider. It's having a width of 4 squares or a width of 6 squares. Now, what does this different width mean? Well, the thing with histograms is that the height of the bear does not represent how many people are in there. So our third bear here is shorter than the first bear, but it's got more people. The first bear has 600 people, and the second one has 660 people. So surely you must think, well, surely that third bear must be taller to show there's more people. But the way histograms work, it's the area shows the number of people. So if you have a look at the first bear in blue and the second bear in blue that we've just drawn, let's think about which one looks like it's bigger. Now, to me, I think that third bear, that second blue bear that we've just drawn, looks a little bit bigger in total, taking into account the width, than the first one. And so it's kind of done its job, and it's only a little bit bigger. So if you're not quite sure, you think they're about the same, that's absolutely fine. They are quite close together, 600 and 660. But again, what we're looking at here, we're not looking at the heights of the bears for the number of people. We're looking at how big the bear is in total, the total area, taking into account the width. Let's look at a few more to get the idea. So the next one is between 176 and 184. Now this is a much narrower bear than what we've had before. It's half the size of some of the other ones. And from 176 to 184, that's a width of 8. 176 plus 8 is 184. So we take the total, 180. We divide it by only 8 this time, and we get in 22.5. The bear's going to go all the way up to 22.5. And you can see this bear is much smaller than all the others. Not only is it not as tall as the other bears, but it's nowhere near as wide as the other bears. And because it's got at least half the width of the other bears, then it looks like it's half the size. So, for example, the other green bear that we drew had 400 people in it. And the second green bear, the one we've just drawn, it's nearly the same height, but it was only 180 people. That's half the number of people. But it's half the width. So you can kind of see the area is half the size, so it's half the number of people. And now moving on to the last one, 184 to 200. So going back to a width of 16, we have 320 people. Divide it by the width, 16 to get 20. Draw the bear going across at 20. And you should be able to see that even though this bear is lower down, it's got less height than the one next to it, it looks a lot bigger than it because the width is so much larger. So again, with histograms, don't look at the heights, look at the total size, taking the height and the width into account. The smallest bear is the fourth bear. It's smallest in terms of how many people it represents, only 180. And it's smallest in terms of the total size, the total area of the bear. What it's not smallest in is the height. But the height is not something we're interested in here, only interested in the area. Moving on to the fourth histogram. So this is for weight. So we're going to look at the total. So in our first line, we have 100 people, and the width of that group, it's in between 40 and 48 kilograms, which is a width of 8. So we're going to divide 100 by 8, and we get 12.5. So we're going to draw a graph in between 40 and 48 and all the way up to 12.5. So we've got a very small bar here. It doesn't represent a lot of people. It only represents 100 people. Now the next bar represents 600 people. That's a lot more. And the width is in between 48 and 64. And that is a width of 16. So we're going to divide by 16. 600 divided by 16 is 37.5. So now we've found 37.5. We've found a starting point, 48. We found the end point, 64. We can draw the bar. Now look how big this bar looks compared to the one next to it. So you can see there are many, many more people in this group. And look at the numbers. There's 600 in the blue bar against 100 in the green bar. So you can imagine size-wise, this blue bar is about 6 times bigger than the green bar. And we're not just talking about the height, the width also shows how much bigger it is. So now moving on to the third one, we're in between 64 and 72, and we have 260 people in total. So if we are going to be in between 64 and 72, that is a width of 8. 64 plus 8 is 72. So we'll take the total, 260, divide it by 8, and we get 32.5. We find 32.5, join up the bar, and this bar is nearly as tall as the blue one we just drew that was quite big. But we can clearly see, because the width is so much smaller, we can see that blue bar is much more people than the green bar just drawn. Even though they're similar heights, the widths are very different. You can look at the numbers, it's kind of 600 people against 260, so there's more than double the number of people in that blue bar. And that's mostly because the width of it being double. Now let's have a look at the next row. We have 480 people, and we're in between 72 and 96. This is a much wider bar here, and in between 72 and 96, it looks like a width of 24. So we're going to divide 480 by 24, and that's going to give me 20 as an answer. Now again, this is quite a large bar, and it's not the tallest bar we've got here. It's shorter than the green bar before it. However, because the width is so much wider, you can clearly see that this must be a much, much bigger group. And again, we look at the numbers, that's 480 people against 260, the one before it. So we can see that that blue bar is definitely at least twice as big as the green bar, and so represents twice as many people at least. Moving on to the next one, we have 96 kilograms all the way up to 104 kilograms. So that's a width of 8. The total is 160. We divide that by the width 8 and we get 20. So this bar is the same height as the one before it. But look at the width, look how much thinner that group is. We can see there are much fewer people in that group than the blue one before it, just because of the relative widths of the two groups. Now moving on to the final row, so this one's got an extra bar in compared to the others, and you can have, any number of bars that you need. We are in between 104 and 120, so we have a width of 16. So we take the total, 320, divide it by 16, and again, we're getting 20. So again, the bar is the same height, but the widths show us that relative to each other, they do have different numbers of people. So again, with histograms, the important thing is the area of each bar, the total size of each bar, not just the heights. Now, the last histogram we're going to draw is for age, and we have in our first row 144 people, and the width is in between 20 years of age and 28 years of age, and that's a width of 8. So we divide 144 by 8, which gives us 18. So the histogram bar is going to go all the way up to 18. Moving on to the next one, the total number of people is 192. So that's larger than the 144 we've just drawn. So this bar should be a little bit bigger than the previous one. We're going to draw it in between 28 and 36, and that is a width of 8 again. So let's divide by 8. 192 divided by 8 is 24. So because the width's the same and it's got more people, this bar is going to be a little bit taller. Now, the next row has 144 people, and that's the same number of people that the first row had. So you'd expect the bars to be the same size, or at least the same area. And it's in between 36 and 44, and that is a width of 8. And 144 divided by 8 gives us 18. And we do have a bar that is the same width and the same height as the first one. And so because they're the same width and the same height, they represent exactly the same number of people. And that should be really clear from the diagram that they're both the same size, both width and height is the same number of people, 144. The next one has 312 people, so this must have a bar that's at least twice as big. So 312 people, what's the width? We're in between 44 and 56. So it's a wider bar. From 44 to 56, that is adding on 12. So we need to divide by 12. So 312 divided by 12 gives us 26. So now not only do we have a bar that is wider than the other ones, it's also taller than the other ones. The area is significantly more, and it's going to represent significantly more people. It's representing 312 people, where the biggest one previously was 192. So it should be bigger than all the others. And then moving on to the last row, this one's only got 96 people in. This should be the smallest one out of all of them. If you look at the width, it's going to be the narrowest bar because we only have between 56 and 60 left. That's a range of 4 years. So 96 divided by 4 gives us 24. Now, because it's quite a narrow space that's left over, it does give us quite a tall bar because a narrower bar means dividing by a smaller number, so we're sharing it less ways. So it's going to end up being taller. Even though this is the second tallest bar in the entire diagram, because of how thin it is, you can clearly see that it's not really anywhere near the other bars in terms of number of people. Certainly the one next to it looks significantly larger, but I think all the others as well look like they are larger than that final bar, even though it is quite tall. Now, as well as drawing a histogram, where you have to use the fact that the frequency density is equal to the frequency divided by the class width, you might also need to work backwards and read the frequency from a histogram. Now, we can rearrange the equation frequency density equals frequency divided by width to get that. So we want to find the frequency. We want the frequency on its own. It's with the divide by the width, so the opposite of that is multiplied by the width. Do that to both sides, and that is going to leave us with the frequency density multiplied by the width is going to give us the frequency. So for each question, being asked to complete the table of heights or ages or heartbeats or whatever it is, and I'm going to do that for each one by multiplying the width of each bar by the frequency density. And if you have a look at it, the frequency density on the y-axis is basically the height. So we're doing the height of the bar multiplied by the width. And that's the same formula for finding the area of a rectangle. So let's have a look at question 1. So we're in between 120 and 144. So that is a width of 24. 120 plus 24 is 144. So the width is 24. We're going to multiply it by the height, which, look on the diagram, is 7. So 24 multiplied by 7 is going to give us 168. Now, I could try and write that in the table. There's not really enough room to show all the questions at once, so I'm just going to write the answers directly onto each bar. Moving on to the second one, the width is in between 144 and 160, so we could take them away. 160 take away 144 is 16, or you could think 144 plus 16 is 160, whichever method you like, but the width is 60. Multiply it by the height, which looks like 5.5 on the graph. So 16 times 5.5 is 88. So we're saying that 88 people have a height in that range of values in between 144 and up to and including 160. Next, we're in between 160 and 176. That'll be a width of 16. The height of the bar is going to be 4.5. So 16 times 4.5 is 72. On to the next bar. It's in between 176 and 184. That's a width of 8. And we're going to multiply the width 8 by the height, which is 7.5, giving us a number of people, the frequency of 60. The next bear also has a width of 8, it's the same width. The height is 4.5, so 8 times 4.5 will give us 36. And the last bear is exactly the same height, it's exactly the same width, that will also be 36. And again, I've put my answers directly onto the diagram just for space reasons, but on exam paper you might need to put these in a nice order in the table. Or you might be asked specifically, what is the area of this one specific bear, and you just write one of the answers as the final answer. For question 2, the first bear is in between 20 and 32, so that will be a width of 12. The height is 20, so 12 times 20 will give us 240 people represented in that first bear. 240 people in between the ages of 20 and 32. Now for the next bear, that goes in between 32 and 40. It's got a width of 8. The height it's going up to is in between 30 and 35. And the number in between 30 and 35 is 32.5. So 8 multiplied by 32.5 will give us 260 people. The next bear is in between 4 and 44. That's a width of 4. The height is 35. 4 times 35 is going to give us 140. The next bear is in between 44 and 52. But I'm going to add 8. 44 plus 8 is 52. I'm going to multiply the width 8 by the height, which is in between 15 and 20. That would be 17.5. That's going to give us 140. That's the same number of people as the bear before it, but you'll notice it's half the height but twice the width. 2 different sized and shaped bears are going to give us the same number of people just because one measurement's doubled and one measurement's halved. Last bear is in between 52 and 60. That's a width of 8. The height is exactly 30. 8 times 30 is going to give us 240. Moving on to question 3. Now look at resting heartbeats. First bear is between 40 and 56. That's a width of 16. The height is 20. 16 times 20 is going to give us 320. The next bear is the same width, so it'll also be 16. The height is in between 16 and 20, that'll be 18, so you should get 288 people. The next bear is in between 72 and 96. Remember, if your mental arithmetic fails you, just subtract them from each other. 96 take away 72 is 24, so the width is 24. Multiply that by the height, 16, and that's going to give us an answer of 384. The next bear is in between 96 and 112. That's a width for 16. Multiply it by the height, 12, and we get in 192. The final bear has a width of 8. It has a height of 20. 8 times 20 is going to give us 160. Now for question 4, we're looking at heights again. The first bear is between 120 and 136. We've got a width of 16. Multiply it by the height, 32.5, and we are getting 520 people. For the second bear, it has a width of 8. It has a height of 25. That's 200 people altogether. Third bear, 144 to 168, is a width of 24. It has a height of 20, so 24 times 20 is going to give us 480. The fourth bear has a width of 8. It has a height of 22.5. So multiply that together and we have 180 people. The next bear is in between 192 and 176. That's a width of 16. Multiply it by the height, 35, and we have 560 people. And for the final bear, it's got a width of 8. It's got a height of 15. 8 times 15 gives us 120. And now moving on to the final question. Our first bear is between 20 and 28. That's a width of 8. Multiply it by the height, 13, and we have 104 people represented in that bear. The next bear is from 28 to 40. That's a width of 12. The height is also 12, so 12 times 12 is 144. The 144 people represented in that bar. Now, the third bar only has a width of 4. It's got a height of 12, like the previous bar. That's going to give us 48 people. Next one also has a width of 4, but this time a height of 7, so that represents 28 people. The next bar has a width of 8. It has a height of 9. 8 times 9 gives us 72. And for the final bar, we have a width of 4. It's the tallest bar, we have a width of 14, and that gives us 56. So even though it's the tallest bar, it doesn't have the most people because it's got that very thin width. So the big thing here is that if you have the width of a group and you have the frequency density, you can work out the frequency by multiplying the width and the frequency density, which is the same as the height together. And it's the same formula for finding the area of a rectangle. Area of each bar is equal to the frequency. Now, moving on to the most difficult histogram questions, we're going to do a bit of problem solving on this. The first question says, find the frequency of heights below 168 centimetres. The first job is to find 168 on your graph and draw a line. So we have 168, and in pink, I'm just going to draw a all the way through. Now, we want to find the frequency of heights below that number. So what I'm going to do now, I'm going to colour in all the bars below that number. Everything I'm colouring in is below 168. It's to the left of 168. Now, what the question is asking us for is, what is the frequency of everything below that line? Everything I've just coloured in pink. So what we need to do now is we need to find the area of all 4 bars that I've shaded in, and the total of the 4 bars is the frequency of all the heights below 168 centimetres. So let's look at the 4. So the first one, from 120 to 136 is a width of 16. It goes all the way up to 15. 16 times 15 is going to give us 240. The second bar is from 152 to 136. That's a width of 16. It goes all the way up to 9. The height's 9. 16 times 9 is going to give us 144. The third bar has a width of 8. It has a height of 10. That's to give us a total of 80. And the fourth bar, it has a width of 8. It has a height of 7. That's going to give us 56 if we do 8 times 7. So now we've worked out the 4 bars that I've shaded in. The 4 bars are less than 168. Add them all together and use a calculator for this. And I'm getting an answer of 520. So there are 520 heights below 168. Now looking at question 2, what the frequency of weights above 88 kilograms. So we find 88. 88 is actually part way through a bar. I'm going to draw it all the way through the graph. And we're looking for weights that are above 88 kilograms. So I'm going to colour in every single part of a bar above that line in pink. Now, even though I've cut that third bar in half, I'm not colouring in the first half. I'm going to leave it alone for now. So we have the full bar at the end that's in between 104 and 120. So that's a width of 16. And that final bar, it goes all the way up to 27.5. So that means there are 440 people represented in the final bar. The question now is, what do we do about that partial bar where our line's gone halfway through it? Well, all we do is we treat it like a brand new bar in our kind of histogram bar chart. I'm using the word bar for bar chart. And it's in between. It's not in between 80 and 104 like the original one. Our new one is in between 88 and 104. So we're only taking a fraction of it. Now, in between 88 and 104, that is 16. 88 plus 16 is 104. So that's our new width. We'll multiply it by the height, 15, and that's going to give us 240, which means our total is going to be 680 people. So again, to be really, really clear here, the actual full bar there was in between 104 and 80, which was the width of 24. And with a height of 15, that means it's 360 people. So the third bar has 360 people in it. We've only taken 240 of them because they're the ones that are above 88. And this is another benefit of histograms, where you can take only part of a group if you need to for a calculation. Now for question 3, what are the weights that are below 72? So we find 72, we draw a line through, identify which bars are below it, the first one and the second one, as all of the second one. And then we're going to find the size of them. So the first one has a width of 8 and a height of 4. That's representing 32 people. The second one has a width of between 72 and 48. Again, you can subtract them from each other if you're not sure, which gives me 24. Multiply it by the height 5, and that is 120 people. That gives us a total of 152 people for the 2 bars that are below 72 kilograms. Question 4 has us looking at heights below 152. So find 152 is the middle of the second group. It's below that, so we're going to colour in everything below it, everything before it. That's 2.5 bars. The first one is in between 144 and 120. That's a width of 24. The height is 5, so 24 times 5 is 120. Now we're going to add on the partial bar next to it. Now up to the line, the width is from 144 to 152, which is a width of 8, multiplied by the height, which is 6. 8 times 6 gives us 48. That is a total of 168. And now moving on to the final question, we want ages that are above 48 years. So we're going to find 48 on the graph and rule off. We're looking at above that number, so we'll just shade in what I'm looking at. And then we're going to find out the area of those. So the first calculation, we have that partial bar, which is in between 48 and 52, which is the width of 4. The height is 12. 4 times 12 is 48. The second one is in between 52 and 60. That's a width of 8. Multiply it by the height 8, and that gives us 64. So for our total, 64 plus the 48 gives us 112 people for the frequency of ages above 48 years. Last thing I want to point out is the relative time I spent in each section. The easy section took us about half an hour, and so drawing histograms can take quite a bit of time, quite a bit of detailed work to make sure you get it right. But now we've only spent 8 minutes on the hard questions, just because kind of calculating, mentally it's a more difficult skill to process, it's more difficult to do, but it's not quite as time.
Ouch! This is why in some videos I have had explained scratches.